तो कोई
क्या?
भाई है क्या थाईलैंड में, है ना?
हाँ तो मैंने बोला हुआ कि पढ़ते हैं।
नहीं, आपने बोला था नहीं है मेरा कोई भाई।
मेरी तो पूरी फैमिली पढ़ी है लर्निंग में।
हाँ लेकिन यू डोंट हैव योर ओन ब्रदर ना इन ट्वेल्थ, तो शायद आपको वो लगा हो उस
नहीं नहीं
वक्त।
नहीं, माय एल्डर ब्रदर आल्सो स्टडीड एट Learnivio and my
योर एल्डर
cousin
ब्रदर?
sister also, my cousin brother also, पूरी
अच्छा,
फैमिली
व्हाट
पढ़ी
वाज
है।
इट? अच्छा, व्हाट इज हिज नेम? आपके बड़े भाई का?
क्रूज में।
आपके बड़े भाई का क्या नाम है जिन्होंने मतलब लर्निंग में ही पढ़ा है लास्ट टाइम?
अब्दुल्ला।
अब्दुल्ला सिद्दीकी।
यस।
ओके, बट आई थिंक ही विल बी इन द इंडियन बैच।
इतना नहीं पता।
हाँ, इंडियन बैच में होगा क्योंकि अब्दुल्ला, आई डोंट थिंक आई हैव टॉट एनीवन हु गोस बाय अब्दुल्ला नेम। या Devangi, the second one is fine. Also, Sunny, then everyone, please send the answer what happened. For the first one, just hide more Yes, Devang, correct. Others, what happened? Hiram, Fahad, Kripa. Yes, Hiram, what happened? Could not get the answer. वन का क्या मतलब है?
So first one.
क्या हो? क्या फर्स्ट वन? ऑक्सीजन और फ्लोरीन में किसका ज्यादा है इलेक्ट्रॉन? यहाँ पे इलेक्ट्रॉन की एंथैल्पी ऑक्सीजन और फ्लोरीन में किसका ज्यादा है?
अच्छा वैसा करना है तो फ्लोरीन
कैसे
का।
करना, क्या वो सवाल से आपको समझ में नहीं आ रहा कैसे करना है? जी, किसका ज्यादा होगा बताइए।
फ्लोरीन।
ठीक है, फर्स्ट में फ्लोरीन का होगा, सेकंड में
सेकंड में भी फ्लोरीन का।
फ्लोरीन का होगा, यानी कि आपने रिवाइज नहीं किया है, पढ़ा नहीं है ना आपने। सी, एक्सपेक्टेड विल बी मोर नेगेटिव, एक्चुअल में क्या है? delta Hg of F is less negative than chlorine. Why? Because the incoming electron gets to the 2p subshell, which is more compact, and that is why there is electronic repulsion. Hence less energy is released. पढ़िए इरम, पढ़िए, बिना रिवाइज किए कुछ नहीं होगा। और व्हाट अबाउट द फॉर्मूला? नहीं आ रहा ये भी आपको?
नहीं वो आ गया सर।
तो वो भेजा
मैं
नहीं आपने।
भेजती हूँ।
व्हाट अबाउट कृपा, व्हाट हैपेंड? यस कृपा,
Yes, sir.
what happened? You did not send me any answers. Did you revise Kripa the last class?
So I just read because the third chapter in our school, it hasn't started. So I just read and I didn't understand it completely.
So you have to message me na, for these things. Like you see, whenever if you have any doubts and all, you don't wait for the class. Okay, you message me instantly. You can have my number. You can ask Learnivio. Okay, for any teacher's number. If you're having other classes also, other subjects, you can ask for their number.
Yeah, okay, sir.
Like next is oxidation state or oxidation number. Oxidation state or oxidation number. Now, what is oxidation state? Whether it can be positive, it can be negative. Either it will be positive or it will be negative or it will be zero. Now, valency, we have seen that all of these are numbers like 3, 2, 1, and so on. but oxidation state will also have a sign with it. So please write the charge which an atom the element has its ion or appears to have when present in combined state. Present in combined state with other atoms. Okay. Now, there are a few things regarding oxidation state that you have to know. For example, if I take a very simple case, start with case 1. Now, in case 1, if you have ionic molecules such as NaCl, MgCl2, then in that case, the oxidation state or the oxidation number, which will be equal to charge on the ion of element. For example, in NaCl, I hope everyone knows that in NaCl we have Na plus and Cl negative, right? Na is giving electrons and Cl is taking electrons, and we have Na plus and Cl negative. So the oxidation state, if I talk about, oxidation number for Na will be +1. For chlorine, it will be what? -1. Similarly, if you have, let us say, MgCl2, in that case, Mg has 2 plus charge, right? And chlorine has 1 negative charge. Can you see that? Chlorine still has 1 negative charge, yes or no? Right, both the chlorines, they have 1 negative charge. Can you see that, yes or no? Please tell me, guys.
Yes, sir.
How it will be balanced? Mg with 2 plus, there is 1 chlorine with a negative charge, 1 chlorine with a negative charge, and that is why this net whole molecule is going to be neutral. So you can say the oxidation state for Mg, it is going to be +2. Oxidation state or oxidation number, it is going to be +2, and for chlorine, still -1. Got it, yes or no? Please tell me, guys.
Yes, sir.
Yes,
Right,
sir.
case 2. Now you can see that in the simple case of what is the oxidation state of H plus ion. So for this, oxidation state is equal to, tell me how much? For H plus, it is equal to how much? What is the charge on H plus? What is the
Plus
charge on H plus? +1. If I talk about, let us say, for example, what is the oxidation state on F negative, then you will call oxidation number or oxidation state is equal to how much for fluorine here?
-1.
-1. Similarly, if I say, for example, O2 negative, then this will be,
-2.
yeah, okay, as simple as that. Right, case 2. Combined state. Okay. Now, there are a few rules for determination of oxidation state of an element or an atom in the combined state. The number 1 is, please see, the oxidation state of an element in free, the elementary state, or in any of its allotropic form is always 0. Basically, oxidation state, it stems from the idea of electronegativity. Okay, so for example, if I talk about helium, I will get helium in its most natural state as helium gas. So in this case, what helium has an oxidation state of 0. Similarly, if you look at H2, which has HH bond, now there is no electronegativity difference between them, right? Like both of them are equally sharing this number of electrons. That is why both of the hydrogen here, it is also having what? The oxidation state as 0. Similarly, O2, which has a double bond. Similarly, you will have N2, which have a triple bond. All of these things, all of the halogens, Cl2, F2, when it is combined with its own atom, then it is what? The oxidation state of that element is going to be always 0. Even you can have P4 carbon, whether it is in graphite state or it is in the state of diamond, all of it has what? Oxidation state which is equal to 0. Got this, yes or no, please tell me, guys? Can I move on, yes or no, please tell me?
Yes, sir.
Okay, right, next. Now, when you have things in the combined form with different elements, please write in compounds, formed by the combination of non-metals, the atom with higher electronegativity, is given negative oxidation state, and the atom with lower electronegativity is given positive oxidation state. For example, see, you have hydrogen and chlorine. Which has higher electronegativity, hydrogen or chlorine? Which has higher electronegativity? Please tell me, guys. Hydrogen or chlorine?
Chlorine.
Chlorine has higher electronegativity. And we have only one bond. So you know that we have one electron here, right? And the electron will be shifted towards chlorine because chlorine has higher electronegativity, higher tendency to pull the electrons. It has higher tendency to pull the electrons, and that is why this chlorine will be having -1 and hydrogen will be having a +1 oxidation state. Okay, +1 oxidation state. Now, if I have something like this, nitrogen with 3 hydrogens. Now tell me, if I look at this two, nitrogen and hydrogen, look at one bond, first of all, which is having higher electronegativity, hydrogen or nitrogen, please tell me, guys. Which is having higher electronegativity, nitrogen or hydrogen?
Nitrogen.
Nitrogen, right? So nitrogen will be what? -1 and hydrogen will be +1. So we have just considered one of the bonds. Now let us look at the second bond. Now here also, this hydrogen will have +1 oxidation state. Nitrogen, due to this particular bond, it will have another -1. And due to this bond also, it will have another -1. So that is why you can see that If you look at each bond and then you look at nitrogen, then it is going to have how much? -3. So by the way, please let me know if my voice is not audible, because I'm getting some notification from Zoom that my internet is unstable. Can you guys hear me properly, or is there any disturbance? Devangi, Aaron, Fahad, please tell me fast. Can you hear me properly?
Yes, sir.
Okay. Now, but if I have fluorine and nitrogen, NF3, in this case, which is more electronegative? Now, these things you have to know which is more electronegative, because it is already done. Fluorine is more electronegative, that is why it will be having -1, and due to this, nitrogen will have +1. Here, fluorine -1, and again +1 for nitrogen, fluorine -1, and +1 for nitrogen. Now, in this case, nitrogen has having an oxidation state of what? +3. Okay, so we cannot give one particular sign or one particular oxidation state to any element in that case. Okay, but for fluorine, we can say that fluorine is always going to be -1, because what? Fluorine is the most electronegative element in the periodic table. But for the other, it will depend on where we have bonded it. Okay, for example, if you look at oxygen atom, so oxygen has this molecule water. So here oxygen is having more electronegativity. So hydrogen will be +1, oxygen will be -1 due to this bond, same +1, and -1 due to this. Now in this case, oxygen is having what? -2. But if I take hydrogen peroxide, hydrogen, oxygen, and then again oxygen, and then hydrogen, this is the structure. Now if I look at this blue bond here with oxygen and hydrogen, due to this, hydrogen has +1, oxygen has -1. Here also it is having -1, and here it is having +1. Okay. So these are the different oxidation states, as you can see here. Then guys, Jasola, please tell me.
Done, sir.
Okay. Now you can see also there is a periodicity in the in the oxidation state, or we can also write about the valence. See, we have already discussed this, but again, just to re-emphasize. I'll write the group number here, and then I will write the number of valence electron. And the valency or the valence. So if I talk about group number 1, the number of valence electron is 1, and all the group 1 elements will have the valence electron 1, and the valency will also be 1. In group 2, the valence electron is 2, and the valency is going to be 2. If I talk about group 13, 13 is going to have 3 valence electrons, and the valency will also be 3. If I talk about 14, valence electron 4, and the valency is also going to be 4. But when I go to 15, in 15, I have a valency, which is valence electron is going to be how much? 5. Now the valency will be, it can be 3 and 5 also. So 5 is there for the elements after the period 3. We will discuss this in the anomalous behavior of the second period elements. Okay, so 3 and 5 are there when you are in the 15th group. Similarly, in 16th, you have 6 valence electron, and the valency is going to be 2 or 6. In 17, we have 7 valence electron, and the valency is going to be 1 or 7. Now in 18th group, the valence electron is equal to 0. So either it will be 0 or it will also be 8. We will look how the noble gas can also form the compounds in the next chapter, that is chapter 4. Okay, so please write this table.
Done, sir.
Done, everyone? Is please tell me, guys. Okay. Right, next. Anomalous behavior of second period elements. Anomalous behavior of second period elements. Now, the second period elements of the groups 1, 2, and then group 13 to 17, they generally differ from the subsequent elements of the groups. Okay. So, for example, if I look at lithium, then lithium, it has a very small Okay. So lithium has what? Lithium has a very small structure, so very small size, and due to which what happens, due to which it just shows more covalent character than the other elements. So please write the first statement. The first element of the groups 1 and 2, sorry, 1 and 2, and groups 13 to 17 differs in many aspects from subsequent elements of the group. Okay. So what are the anomalous behavior? So like first point. The first element of group 1 and group 2 that means we have what? Lithium and beryllium, right? We have lithium and beryllium. No, that is lithium and beryllium from compounds with high covalent nature. High covalent nature due to their small size. Due to their small size. Right, next point. The first elements, or rather you will write like this, the second period elements, sorry, the second period elements only have 4 valence orbitals. That is 2s. In 2s we have 1 orbital, and then in 2p we have the 3 orbitals. So it has only 4 valence orbital, and hence can accommodate if we have 4 orbitals, how many electrons will be there? Please tell me, guys, in the valence shell. If we have 4 orbitals, That means how many electrons? 4 orbitals means how many electrons, guys? Hiram, tell me. 4 electrons means how many? 4 orbitals mean how many electrons?
8.
So it can accommodate only 8 electrons. Whereas the elements of third period and beyond have how many? They have 3s, 3p, and 3d orbitals, and hence can accommodate more than 8 electrons. Done, guys? This one, please tell me.
Yes, sir.
Okay, right, next. The second period elements also exhibit greater tendency to form p pi double multiple bonds rather than double p pi multiple bonds. Due to their small size.
Done, sir.
Done, everyone? Okay. Right, next. Reasons for anomalous behavior of second period element. Number 1, very small size. As compared to subsequent elements, subsequent group members. Second point, please write. High electronegativity Okay, so they have mostly quite high electronegativity. Third point, which is very important, absence of B subshell. Okay, absence of B subshell. So these are the most important point due to which the second period elements they show anomalous behavior. The absence of D subshell, it is going to be very important. So please remember that the second period elements, they can only have 8 electrons, not more than 8 electrons, but the subsequent elements, they can have, subsequent group members, they can have what, more than 8 electrons in their valence shell because they have the D subshell. In D subshell, they can accommodate more than 8 electrons. Done, guys? Yes or no, please tell me.
Yes, sir.
Right, next, the diagonal relationship. Now, the elements such as lithium and magnesium, beryllium and aluminium. So they generally show similar properties. Okay. Why is that happening? Let me show you. In the first group, we have lithium, sodium. Please don't write this. Potassium, rubidium, cesium, and francium. And then we have beryllium, magnesium, calcium, strontium, barium, and radium. Then we have boron, aluminium, indium, thallium, Tl. Okay, but we don't need these things. Okay, we don't need these things. Now, guys, tell me, what happens if I go from beryllium to lithium? The size increases or decreases? From beryllium to lithium, what happens? Size increases or decreases? Think and tell me.
Increases.
The size increases. Very good. What happens if I go from beryllium to magnesium? Size increases or decreases?
Increases.
Increases. Okay. And due to this similar sizes, and we have seen that each and every physical property that we have seen, starting from ionization enthalpy to electron gain enthalpy, electron activity, all of them, they majorly depend on what? They majorly depend on the size of the atom. If you look at the lithium atom has a radius of 152 picometers, and magnesium has 160. You compare this to sodium, that is going to be having 186. Beryllium, it has, I think it is 111. Boron is 88, and aluminium is 143. Okay. So actually what happens, see here, if you don't want to remember the numbers, what is happening? Beryllium to lithium size is increasing. Beryllium to magnesium size is increasing. And that is why lithium and magnesium, they will show some resemblance. Okay. They will show some resemblance. Similarly, if I talk about boron to beryllium, the size is what? The size is increasing. And beryllium to aluminium also the size is increasing. And that is why beryllium and aluminium also, they will show some similarities. Now this relationship is known as, can you see, it is making a diagonal, so it is known as diagonal relationship. You guys got it? Yes or no? Please tell me. Tell me, guys, did you get this? Yes or no? What happened, guys? आप लोग आंसर क्यों नहीं कर रहे हैं? नहीं समझ में आया तो नहीं समझ में आया बोलिए, समझ में आया तो समझ में आया बोलिए. What about others? Devangi, Iram, Kripa?
Sir, it's just because of the size.
It is just because of the size of ions, and more importantly, the size of ions, if not the size of atom, more importantly, the size of ion, because in chemistry, there will be always going to be reactions, and in reactions, what happen? The electron will be released by these metals. Okay, so the size of ions are more important factor here. That is only because of the size.
Okay, sir.
Okay. Right here. So what is diagonal relationship? How can we define diagonal relationship? We can say that elements like lithium and beryllium, elements and like lithium and beryllium show similarity with second element of the next group. That is magnesium and aluminium respectively. This similarity is known as diagonal relationship. Right, next point. Diagonal relationship exists due to identical size of ions. Okay, and we can say, like, as we move leftwards in a period, the size increases, and similarly as we move down the group, size increases. Okay, down the group, size increases. This leads to identical size of ions. Right, next. Elements present in a diagonal to each other exhibit similar property. Now, wherever size is there, it is going to deliver similar properties. For example, even starting with density, because density has a component of volume, density, atomic size is always already there. That is also the cause, electronegativity. Polarizing power. Okay, and the other elements also. Done, everyone? Yes or no? Please tell me, guys.
So what's polarizing power?
Polarizing power. Okay, sir. Let us talk about lithium. Okay, so lithium will be lithium positive. I'm taking element lithium chloride, and similarly, I'm taking a very down the group cesium chloride. So Cs positive, and here we have chlorine negative, and here also we have chlorine negative. Okay, now you see here. When I have lithium positive, I can represent it like this. Right? Yes or no? Please tell me. And similarly, I can give chlorine negative a bigger size because it is third period element. Something like this. Correct? You understand the scenario for lithium positive and chlorine negative?
Yes, sir.
Okay. Now for cesium, obviously the size of cesium will be a bit larger because my bad. It will be even larger than this, but I'm just making it this. There's no change in chlorine. Oh, sorry, I have to copy and paste it. Yeah. Okay. Polarizing power means if you look at this positive charge, if you look at this positive lithium positive ion, so lithium positive ion is quite small. Lithium positive ion is quite small, and if it is quite small, this is positive charge. Positive charge will be where in nucleus? Yes or no? Please tell me. Correct?
Yes, sir.
And negative charge will be on where? Nucleus may or outer outside the nucleus with the electrons. The negative charge is due to what? The electrons, right? Negative charge will be there due to extra electron. Yes or no?
Yes, sir.
Okay, fine. Now, electrons, they can be attracted, correct? So this small charge, because it is very concentrated at one particular point, it will attract this electron cloud like this. Okay, so what will happen? This ion will be polarized like this. You will have a positive ion like this, and the negative ion will it will look something like this. So can you see it is getting polarized towards a point? Are you
Yes,
with
sir.
me? Can you see this happening? Right? What will happen? But as you see here we don't have a positive charge in concentrated at a very particular point because the size of ion is very huge, right? The size of ion is very huge. This positive charge will not be able to polarize this negative charge. Can you see that also happening? Yes or no? Please tell me, guys. In the second case, Devang.
Yes, sir.
Father Kripa. having a very large size, this negative charge ये कहाँ पे attract होगा बताइए? ये पूरी तरह से यहाँ पे ऐसे shift हो सकता है बस. Yes or no? Correct?
Yes, sir.
Because आप देखिए यहाँ पे attract कौन कर रहा है? Think in those terms. This negative charge will be attracted from each and every point, ना? ठीक है, पूरे पॉइंट से इसका अट्रैक्ट कर रहा है. बट इफ यू लुक एट दिस small positive charge, then this small positive charge will be attracting in a manner like this. Yes or no? And that is why you see that there is a polarization there. समझ में आ रहा है नहीं आ रहा? Please tell me.
Yes, sir.
What about others? Now can you see it polarizing like this? Yes, Kripa, Fahad, Iram, tell me. Yes or no? कुछ नहीं बताना है क्या आप लोगों को?
Yes, sir.
What about you guys, Iram and Fahad?
Yes, sir.
नहीं, हमको नाम नहीं लेना पड़ना चाहिए इरम, ठीक है? Similarly, Fahad, Kripa, when I am asking something, you answer it either yes or no. अगर समझ में नहीं आ रहा तो आप ना बोलिए, अगर आ रहा है तो हाँ बोलिए. Right, next, oxides of metal, non-metals. Just write the topic oxides. Write the first point. Oxides of extreme left elements in modern periodic table are mostly basic. For example, Na2O or magnesium oxide, etc. Right, next, oxides of extreme right. Oxides of extreme right elements in modern periodic table are mostly acidic. For example, Cl2O7. Right, next, oxides of center are amphoteric. Okay, are amphoteric or they are neutral. The neutral one are carbon monoxide, nitrous acid, and oh sorry, not NO2, N2O.
Done, sir.
The question. Chemical reaction with water. That sodium oxide is basic. Chloric oxide is acidic. Now, if I look at sodium 2O, then we have Na plus, and O2 negative. This type of ions are present in Na2O. It is an ionic molecule. Now, I want to focus here. So we have sodium plus ions and O2 negative ions. I'm just deleting this one because we have only these type. These are the two different types of ion that we have in water. If I look at H2O, now water is going to have hydrogen, oxygen, and then hydrogen. And this oxygen is going to have what? Delta negative charge because it is more electronegative. Now, when we have electron-rich oxygen atom, it is going to attack on the Na plus. It is going to get attracted. It is going to get attracted. When it will get attracted, you will have something like this: sodium. It has a bond with oxygen atom. Now it has a bond with hydrogen. Now it has a bond with another hydrogen. Now, when we have something like this oxygen is now having a bond with three different elements, right? Three different atoms. So it will get a positive charge. Now imagine the state of hydrogen atom. The hydrogen atom here, it is what? The hydrogen atom here, it is having delta positive charge, right? Because it is attached to electronegative oxygen atom. Now the oxygen atom, on top of the higher electronegativity, it is having a positive charge. Now, what the role of positive charge is here, what? It is attract even more electrons. Now, when it is going to attract even more electrons, then what is going to happen? This oxygen negative, which because it is having what? 2 negative charge, it will come and it will attack on this. It will get attracted towards this hydrogen. And what you are going to get? You are going to get NaOH plus this oxygen, which is getting attracted towards the hydrogen. It will give one electron to hydrogen and it will make a bond, OH bond, and there will be a negative charge here. As you can see, the complete scenario is giving rise to a base, that is NaOH, and also it is increasing the concentration of OH negative ions. It is also increasing the concentration of OH negative ions. So we'll write a reaction like this. This is the mechanism if you want to understand. But the reaction is going to be like this: Na2O plus H2O is going to give you NaOH. Okay, we can balance it as there will be 2 NaOH. Okay, and if you have Cl2O7 plus H2, this is going to give you 2HClO4. This is a base. This is an acid. Done, everyone? Yes or no? Please tell me, guys. Devaki, can you please turn your mic on?
Yes, sir.
So in Na2O, you understand that we are going to have only Na plus ion, and the other ion that we will be having is O2 negative. Yes or no?
Yes, sir.
You're okay with the charges?
Yes, sir.
You're okay with the charge delta negative on oxygen and delta positive on the hydrogen? Yes or no? Tell me.
So what is delta?
Delta means small.
Okay, sir.
Some positive charge and some negative charge. We cannot give exact numbers. then we write delta positive and delta negative to represent that it is having some negative charge and hydrogen is having some positive charge. Now you tell me, this oxygen will be attracted towards Na, yes or no?
Yes, sir.
Okay. Then we will get this, correct? Can you see
Sir,
that?
how oxygen became positive?
Okay. Oxygen has how many electrons, tell me, in the valence shell?
6.
6 electrons. Okay. Now, out of these 6 electrons, if you see here, यहाँ पे आपके पास 2 lone pair होंगे. I don't know because this bonding part इस तरह से होंगे. ठीक है. Now, it has 6 valence electron, and how many electrons are there in the inner shell? Inner shell में कितना होता है? Total electrons कितने होते हैं देवांगी, ये बता दीजिए. Total electrons कितने होते हैं?
16.
16 नहीं, 8 होते हैं ना. Atomic number 8 है, number of protons 8 होंगे, number of
Yes, sir.
electrons 8 होंगे. It has total of 8 electrons. Okay, it has total of 8 electrons. Now, अब यहाँ पे देखिए, यहाँ पे ऑक्सीजन के पास ये इसका अपना इलेक्ट्रॉन है, ये इसका अपना इलेक्ट्रॉन, सही है?
Yes, sir.
Correct? And the hydrogens are having these electrons. तो कोई किसी को इलेक्ट्रॉन दे रहा है क्या? कोई किसी को इलेक्ट्रॉन दे नहीं रहा है, right? They are sharing just the electrons, correct? देवांगी?
Yes, sir.
Now, each bond requires how many electrons? What can you see? Each bond requires how many electrons?
2.
2 electrons. ठीक है. अब बताइए, यहाँ सोडियम के पास तो कोई भी इलेक्ट्रॉन बचा हुआ नहीं है, right? We don't have any electrons in the sodium plus because it is already given electrons, right?
Yes, sir.
Okay. Now, when oxygen is going to bond with sodium, so it is going to use both of its electron like this. Can you see that?
Okay, sir.
Okay, because it needs, because for it has to bond, and in order to bond, it requires 2 electrons. Sodium does not have any valence electron. So what will oxygen do? Oxygen will give both of the electrons because it has 4 electrons which are not having any bonds. So 2 of those will be there and they will bond with sodium. And now you can see that oxygen has how many electrons? It has 1 electron here. There will be a lone pair like this. Now this electron, I'm just coloring it as blue because it is not inside oxygen right now. It is gone away from oxygen towards sodium atom. And then it has these 2 lone pair and this electron and this electron. So how many electrons can you see here? Tell me, Devangi. 5 can you see?
5.
हाँ, और उसके it will be having 1s2, 2s2, and 2p में you will be having how many electrons here? 2p में you will be having 3 electrons, right? Total electrons से कितने हो जाएंगे? 7 इलेक्ट्रॉन. पहले देख रहे थे, पहले कितना था? 6 इलेक्ट्रॉन था वैलेंस शेल में, अब कितना है? 5 है. So decrease in electron, that is going to give it a positive charge. बात समझ में आ रही है? Yes or no, please tell me.
Yes, sir.
ठीक है. पहले कितने थे इलेक्ट्रॉन उसके पास? Before bonding to sodium?
6.
6. After bonding to sodium, now it has how many in the valence shell?
5.
5. इलेक्ट्रॉन घट गया तो पॉजिटिव चार्ज आ जाएगा.
Yes, sir.
ठीक है. चलिए. And when there will be positive charge, the hydrogen atoms it will be getting more and more positive because see, oxygen is electronegative, and on top of that it has now positive charge. Now that positive charge is also pulling the electrons. The electronegative atom oxygen it is also pulling the electron. Now the hydrogen will become very much delta positive. That means electron deficient, electron poor, and this O2 negative then it will attack. और ये O2 negative क्या करेगा? It will give 1 electron, and if it will give 1 electron, तो उसका 1 electron का charge जो क्या हो जाएगा? कम हो जाएगा हाइड्रोजन के पास से, because already this hydrogen is having positive charge. That means ये जो इलेक्ट्रॉन हाइड्रोजन जो टूटेगा यहाँ से, it will leave its electron. It is going to leave its electron, and it is going to get attached with O2 negative. So we will have something like this: O2 negative plus H, O2 negative plus H positive from the NaOH, and here we will be getting OH negative. 2 minus and 1 plus, it is going to give you 1 negative. Got it, Devangi?
Yes, sir.
right next. There is a small portion in which I have to deal with oxidizing property. Okay. Oxidizing property of some elements. Oxidizing property of some element. Now, oxidizing and reducing properties, these are two different things. So when I talk about oxidizing and reducing, पहले इसको समझ लीजिए that what are these terms. Reduction means gain of electron. Okay, reduction means gain of electron. Oxidation means loss of electron. Oxidation means loss of electron. Now, reduction is gain of electron, and then we have reducing agent. Okay, we have reducing agent. Now, reducing agent provides the electron. For reduction. All of you know there is a term which is known as travel agent. There is a carrier which is known as travel agent. Yes or no? Please tell me, guys. Yes or no? All of you know, no? Travel agent. ट्रैवल एजेंट
Yes.
नहीं पता है, भगा देंगे आप लोग को, सच में बता रहे क्लास से बंद कर देंगे ये वाला बैच, आप लोग आंसर नहीं कीजिएगा तो, एंड दैट इज रियली नॉट अ थ्रेट. नहीं पढ़ना तो फिर मत आइए यहाँ पे. So when we have reducing travel agent, they don't travel, they will give you tickets, they provide, they will facilitate the travel there. Now reducing agent is going to facilitate the reduction. That means it is going to provide the electron. So reducing agent is going to provide the electron. That means a good reducing agent should easily lose electron. A good reducing agent should do what? It should easily lose electron and it should facilitate the reduction. In oxidation, there will be an oxidizing agent. Oxidizing agent, when we have loss of electron, then the oxidizing agent, it will be there in order to eat up the electron. Because someone is losing electrons, oxidizing agent will facilitate that loss, and in order to that element to lose electron, the oxidizing agent will eat up the electron. Okay, so what it will do, oxidizing agent eats the electron, or we can write gains electron. A good oxidizing agent should easily gain electron. Now, a good reducing agent should easily lose electron. That means that is the ionization enthalpy should be low. It should easily, a good reducing agent should have low ionization enthalpy. A good oxidizing agent should gain the electron easily, and it should have delta H Eg more negative.
Done, sir.
Okay, another question. Arrange the following in increasing order. of oxidizing property. Okay. Generally, oxidizing property, these are experimental. They are determined experimentally, but we can also have some kind of idea about which is going to have higher oxidation potential and which is going to have lower oxidation potential, lower oxidizing property and higher oxidizing property. I have the element fluorine, oxygen, and nitrogen. You just have to arrange them. Think in the terms of electronegativity and also the electron gain enthalpy. So if we consider each and everything, then see fluorine has a lower electron gain enthalpy, but it has a very high electronegativity, and that gives fluorine a very high oxidizing power. That means it is going to gain electron very easily. Okay. Now chlorine, then we have oxygen. Because of its smaller size, it is going to attract and it can add electron very easily. After that, we have the chlorine and nitrogen. And chlorine and nitrogen, we have chlorine first because nitrogen has very small size, but it does not have that many electrons in order to pull the incoming electron. And after that, we have nitrogen. Now, moreover, this oxidizing property, you will read about this. This is only one question in your NCERT, which is this about oxidizing property. Even in NCERT, they say that you will read this in the next chapter, that is redox reaction. Okay, in the redox reaction, you are going to learn more about oxidation and reduction, and in more detail you will see. And then again, you will see the exact theoretical and the experimental numbers that we get for what is the tendency of fluorine and oxygen and chlorine and nitrogen to gain electron, and that is in electrochemistry in the 12th standard. So this in electrochemistry, you will deal with detailed numbers, but the theoretical concept of oxidation and reduction will be completed in the redox reaction. As of now, you can write here just because of small size and high Z, that means nuclear charge is very high. Similarly, here also small size and Z is very high. Now here we have high number of Z, that is why it is next. And here we have, like, both of the things are not very, like, even the size is what? Size is also, if you compare, it is going to be high, and even the number of proton is also going to be low, right? So both of these criteria, if you see, and nitrogen is going to have a less oxidizing property, less oxidizing power. But again, electron gain enthalpy and electron negativity are not the only things which determine the oxidizing property. It also depends on other things. You will also read this a little bit in thermodynamics also.